Hi folks, today we're going to talk about factoring the sum and difference of cubes. So this is one of the last kind of special cases that we talk about with factoring before we talk about using factoring to do other things. So today we're going to talk about the sum and difference of cubes, and the sum means adding and the difference means subtracting, and cubes means something raised to the power of 3. So it could be a variable, it could be like a number, so 2 raised to the power of 3 would be 8, so 8 is a cube. So just things that are raised to the power of 3, those are cubes. So we have two essential questions today. The first is, what is a sum or difference of cubes? And the second essential question is, how do we factor a sum or difference of cubes? Okay. So the first question, we kind of talked about what it was, or at least the pieces that made up a sum or difference of cubes. And the way that we factor the sum or difference of cubes is by using the formulas. And so if you're using Kami to annotate your notes, you might want to use that highlighter tool and highlight the formulas for the sum of cubes. There we go. And the difference of cubes. These are things that you would find on like an Algebra 2 formula chart. These formulas are found on the formula charts. However, it is a good idea to have these memorized. And there's an easy way to memorize them. I'll show you how to do that in a second. But the sum of cubes and the difference of cubes look like this. It's what the problems look like. Now, obviously, we talked about how the variable might instead be a number cubed, and then you might have like a coefficient here. So you might have x cubed plus 8 or something like that, where a is x and b is the thing that you cube to get 8. So 2 cubed is 8. So that means that b is 2. And those a's and b's show up in your formula. Now, if you notice, both the sum of cubes and the difference of cubes have an answer, a factored format that look pretty identical with the exception of the signs. So we've got plus minus plus, we've got minus plus plus. So those are the things that make it a little bit different, which kind of makes sense because the only thing that's different about the sum and difference of cubes is the sum and the difference, so the plus and the minus. So when you're factoring the sum and difference of cubes, you always want to factor out the GCF if possible. Remember that if a problem has a GCF that you can factor out, that means that once you take it out, your numbers and your variables are smaller, and they're simpler, and they're easier to use. The next thing that you want to remember is SOAP. And we talk about this every year that we teach this topic, but this year more than ever, SOAP is kind of important to us. So SOAP helps you remember the signs. So remember signs. Remember how we said that the only real difference between the sum and difference of cubes format for the factorization is the signs, the pluses and the minuses? Well, the way that you can remember is based on the original problem, whether it's a sum or a difference. The first sign in the factored form is going to be the same as in the problem. So if this is a plus, first sign will be a plus. If this is a minus, first sign will be a minus. The next sign will be the opposite. So if this is a plus, then this will be a plus and a minus. If this is a minus, then this will be a minus and a plus. So see how the second sign is the opposite? And then finally, the last sign is a plus and a plus. So it's always either plus, or you can think always positive. Either is fine. Now, a sum or difference of cubes will always have coefficients that are perfect cubes. And if you're unsure what a perfect cube is, think about what we talked about up here. A cube is something that you take a number and you cube it and you get a perfect cube. And so perfect cubes for coefficients are actually listed down here for you. They're not perfect squares, they are perfect cubes. So 1 cubed is 1. This is a perfect cube. 2 cubed is 8. 8 is a perfect cube. 27 is a perfect cube. 64 is a perfect cube, and so on. So we've got the perfect cubes all the way to 1,000, all the way to 10 cubed, and that way they're easy reference for you. Hopefully you will see them enough and use them enough that they'll kind of become ingrained in your memory. Exponents, before, when we did like difference of two squares, exponents needed to be divisible by 2. They needed to be even. But since we're not talking about difference of squares, we're talking about sum and difference of cubes, exponents need to be divisible by 3. Remember how we talked about cubes being like x cubed? Well, this 3 is divisible by 3. That means that it's a perfect cube. I could also have like x to the power of 6 because 6 is a perfect cube. The factors in your answer will be a binomial and then a trinomial. So that's why you have step 5 here. Now, we know what it looks like now, but we need to be able to find a and b in order to put them into the formulas. So a and b, we need to square a, multiply a times b, square b. So we need to find a and b, and in order to do that, you're going to take the cube root of each term. Now, if your term is a variable raised to a power, well, then that's simple. You can divide the exponent by 3 and be done. But if your if your term is not a variable raised to a power, then you've got to actually find the cube root. So I'm going to give you an example of what that looks like. Now, so far in math, you've probably only thought about taking the square root. So if I have the square root of 16, there's kind of an implied 2 here because I'm trying to break 16 up into 2 of the same thing that when multiplied together will give you an answer. So what times itself is 16? Well, the answer is 4. 4 times 4 is 16. 4 times itself 2 times is 16. So that means the square root of 16 is 4. However, if I want the cube root of something, that means that I need to figure out what times itself 3 times will give me the number inside, called the radicand. So if I think about 64, well, 4 times 4 is 16, and 16 times another 4 is 64. So that means that the cube root of 64 is 4. Up top, the cube root of 8 is 2, because 2 times 2 times 2 is 8. So that just kind of gives you an idea of how to find the cube root of coefficients. So I'm going to go down to my examples. It says factor completely. I notice that I have the sum. I notice that these are 2 cubes. This is a perfect cube because it has an exponent divisible by 3. And this is a perfect cube because we just found out that it was a perfect cube. It also is in my list. So if I factor completely, I need to find my square root of x cubed. Well, or sorry, my cube root of x cubed. One of the ways that we've kind of helped students in the past find the cube root of variables raised to a power is to kind of cover up this and ignore the x. And what that ends up kind of looking like is 3 divided by 3. And 3 divided by 3 is 1. So this is really x to the power of 1. That's my a. And then the cube root of 64, right here, that's 4. So that's my b value. So a squared is x squared. A times b is x times 4. And b squared is 4 squared, so 16. So now I have all the pieces that go into my formula. I notice that, excuse me, I notice that this is the sum of 2 squares. That means that my formula will have a sum, a difference, and then a plus sign at the end. So a plus b, x plus 4, times a squared, which is x squared, minus AB, which is minus 4x, plus b squared, which is plus 16. And that's it. That's my factored form. So let's try number 2. Number 2, I notice, is a difference. It's a binomial, so it has the opportunity to be the difference of squares or the difference of cubes. But I notice that this is divisible by 3, so I'm going to go with the difference of cubes. The cube root of 8. 8 is on my list, so the cube root is 2. And here the cube root of 27x cubed. Well, the cube root of x cubed, we found out before, is just x to the power of 3 divided by 3, so x to the power of 1. And then the cube root of 27, well, that shows up here, and that's 3. So my first term, the a value is 2. My second term, the b value is 3x. If I combine a and b the way that I'm supposed to in my formula, a squared is 2 squared. AB is a times b. And b squared is 3x times 3x. So 3 times 3 is 9, x times x is x squared. This is a difference of 2 squares, so my formula will have a minus sign, a plus sign, and then always a plus sign. So my formula is a minus b. A minus b, so 2 minus 3x. And then a squared, which is 4, plus ab, which is 6x, plus b squared, which is 9x squared. Okay. Last problem, hang on just a moment. So the last problem is a binomial. It's a sum. I notice that my exponents are 3 and 3 and 9. So these are all perfect cubes. I'd like to check and make sure that 16 is a perfect cube and 250 is a perfect cube, but I don't see those on there. 16 should be, 16 should be right between 8 and 27, and it's not. And 250 should be right between 216 and 343, and it's not. So do you notice anything about number 3? If you thought to yourself, okay, these numbers are big, take out a GCF, then you would be right. So for this problem, I can definitely take out a 2, right? Because they're both even. I also notice that they both have y cubed that they could give up. Right? So this is 2y cubed. 250 divided by 2, that would be 125. X cubed is still there, but y cubed got taken out in the GCF, plus 16 divided by 2 is 8. And y to the power of 9 over y to the power of 3, that's y to the power of 9 minus 3, which is 6. So now the 125 is a perfect cube and the 8 is a perfect cube. So we're able to continue with our sum of cubes formula. So if I square root if I cube root 125x cubed, the cube root of 125 is 5. The cube root of x cubed is x. If I cube root, 8y to the power of 6, the cube root of 8 is 2. The cube root of y to the power of 6, well, what's 6 divided by 3? 6 divided by 3 is 2, so the new exponent is 2. So my formula, and I should have my GCF out in the front, my formula is same sign, so a plus sign, opposite sign, so a minus sign, and then always a positive. I should have a plus b in the first binomial, so 5x plus 2y squared. And then for my trinomial, I should have a squared, so 5x squared. If I square 5, that's 25. If I square x, that's x squared. Minus ab, so a times a times b times b. So a times b would be 5x times 2y squared. 5 times 2 is 10, x, y squared. And then b times b, that would be 2y squared times itself. So 2 squared is 4, y squared is y to the power of 4. And there is my factored answer.